Okay, as promised, this is a video on the last part of the Unit 2 test review. Okay, so this is what we did in class on Thursday, and we were going over it, and we just didn't have quite enough time to finish going over problems 4 and 5. Okay, so for problem 4, we have two word problems involving systems of equations. Okay, so the first problem says a movie theater sells tickets for adults and children. One day, the theater sold 120 tickets in total and collected $1,050 in ticket sales. An adult ticket costs $10 and a child's ticket costs $5. How many adult tickets and how many child tickets were sold that day? Well, you always have to assign a variable. And when you're dealing with systems of equations, you kind of have two things that you're looking for. In this case, we're looking for the number of tickets sold for adults versus kids, also the amount of money brought in. So based on the amount of money brought in, how does that help us figure out how many adult tickets were sold compared to how many kids tickets were sold? Okay, so while they're really only asking how many tickets were sold, we need two pieces of information to help us figure it out. Okay, so because we have these two pieces of information and we have these two variables, this is definitely going to be a system of equations in two variables. So let's go ahead and assign variables. Now, when you're doing word problems, you can assign really any kind of variable you want. So since we're looking for adult tickets and child's tickets, you could use A's and C's, you could use X's and Y's, you could use any variable you want. Okay, so go ahead and assign your variables. So let's say we let X equal an adult ticket and Y is going to equal a child ticket. Okay. Now we have two things that are happening. We have the number of tickets sold and the amount of money brought in from ticket sales. So if we take the number of adult tickets, add it to the number of child's tickets, we know that 120 tickets were sold total. So that's our first equation. Okay. And that's based on the information given here. Now, we also know that from those 120 tickets that were sold, we brought in $1,050. Okay. So for each adult ticket that was sold, we made $10. For each child's ticket sold, we made $5. So we have to come up with an equation that represents the ticket sales. Okay. Well, for each ticket sold for an adult, we made $10. For each ticket sold to a child, we made $5, and that ended up being $1,050 total. So this right here is our system of equations. Okay, now as for how you want to solve this, you could solve this using the addition slash elimination method or substitution. Either one is fine. For this one, let's say we do, let's do substitution. So let's solve this top equation for one of the two variables. Let's say we solve it for X. Okay, so if I have X plus Y equals 120, and I want to solve for X, I would need to subtract Y from both sides. So that would tell me that X equals negative Y plus 120, or you could say 120 minus Y. Doesn't matter. Either way, what we're going to do is we're going to take this value for X and we're going to plug it into the other equation for X. Okay? So that's going to give me 10 times negative Y plus 120. And then don't forget the 5Y, the equals, and the 1050 or the 1050. Okay. So now we have an equation that just contains y's that we can use our steps that we learned in chapter 2. We can use those steps from chapter 2 to solve this. Okay. First thing I need to do is distribute my 10. So 10 times negative y is negative 10y. 10 times 120 is 1200. And then don't forget you have your plus 5y equals 1050. Now we want to combine like terms, and my like terms are negative 10y and 5y. Well, negative 10y plus 5y is just negative 5y. So I get negative 5y plus 1200 equals 1050. Now I want to subtract 1200 from both sides. Let me erase a little bit of side work so I have more room, because I'm just about out of room down here and I don't want it to get too scrunched. So what we have now is negative 5y plus 1200 is 1050. To get my negative 5y alone, I want to subtract 1200 from both sides. Well, 1200 minus 1200 is 0, so that leaves me with negative 5y equals. And then 1050 minus 1200 is negative 150. I need to divide both sides by negative 5. Well, negative 5 divided by itself is positive 1, and then that just leaves me 1 times y. And then let's see, negative 150 divided by 5 is 30. Okay, so what is Y? Well, Y was the number of children's tickets sold. So we have 30 children's tickets sold. Okay, and if I take X plus Y, which is 30, that has to equal 120 based on this first equation right here. Okay, so doing just a little arithmetic, I can figure out how many adult tickets were sold. So I would subtract 30 from both sides. 30 minus 30 is 0, so I get X equals 90. Now I am flat dab out of room. I didn't plan very well for this one. So we would say 90 adult tickets and 30 kids tickets or child tickets. And that would be our final answer. Okay. So sorry, I did run out of room. I didn't plan for my solving very well here. Okay, but there you have it. That would be the process for solving this one. Now, when it comes to actually solving the system of equations, you could have solved using the addition method as well. Just kind of comes down to your preference when you're dealing with word problems. Sometimes there's a system that is really designed to be easier for one method or the other, but really you can use either one. Okay, for part B, we have Maria has $10,000 to invest and wants to divide it between two savings accounts. One account pays 3% annual interest. The other account pays 5% annual interest. Okay, she wants to earn a total of $420 in interest. So basically, when you invest money, the bank pays you to use your money while you're not using it. So you're earning interest. Okay, so you park money in the bank and you earn interest. So it's like extra money that you earn on what you deposited. Okay, so in this case, we know that one of the accounts is going to pay 3%. So you get 3% of what you invest per year. The other is going to pay 5%. And this particular person, what was her name? Maria? Yeah, Maria, she wants to make sure she earns at least $420 a year in interest. Okay, so let's assign variables. So let's say we let X equal the 5% account, and we're going to let Y equal the 3% account. Okay. Now we have two things that are going on. How much is invested in each account and then how much interest is earned from each account. So the first equation is easy. If we take the amount invested at the 5% account and the amount invested in the 3% account, we get X plus Y equals 10,000. We know Maria has $10,000 total that she's investing. Okay. Now, in these accounts, we're going to earn interest. So for the 5% account, we're going to get 5% of whatever we deposit in that account. So the way we would write 5% as a decimal is 0.05. So we're going to get 0.05 times X. That's the amount we invest in the 5% account. Plus, well, 3%, we would write it as 0.03. So I'm going to get plus 0.03y, and that needs to equal the interest earned in a year. So Maria's hoping to earn at least $420 in interest a year. And so now you have two equations. And again, it does not matter which method you use to solve. You could use substitution, elimination, or you could use substitution, or you could use elimination slash addition. So just for the sake of practice, let's say we did substitution last time. Let's do elimination this time. So let's just pretend that we all decided we were going to get rid of x's. Well, in order to get rid of x's, the x's on these two accounts need to have opposite coefficients. So the x in the second account already has a coefficient of 0.05. So we need to force the coefficient on the other equation to have negative 0.05. So in order to do that, we're going to multiply the whole second equation by negative 0.05. So that's going to give me negative 0.05x minus 0.05y equals, and we want to multiply 10,000 by 0.05. So if you need to, pull out a calculator. Now, when you're dealing with powers of 10 like this, it's not too hard, but if you need a calculator, use the calculator. When we multiply by 0.05, we get negative 500. And then don't forget the second equation, we're not changing it. It's going to stay 0.05x plus 0.03y equals positive 420. Okay, and then what we want to do for the not substitution, please don't do substitution. For the addition elimination method, we want to add the two equations. And when we add the two equations, the x's completely cancel out. Okay, so when I add my y's, I get negative 0.02y. And then when I add negative 500 and 420, I get negative 80. And then to get y alone, I want to divide both sides by negative 0.02. Well, negative 0.02 divided by itself is just positive y. And then 80 divided by negative, or negative 80 divided by negative 0.02 is 4,000. So we're going to invest 4,000 at 3%. And that means the remainder of the $10,000. So we've got 10,000 total. We know we've already invested 4,000 at 3%. That's going to leave me 6,000 at 5%. So those are the two word problems. I was able to set them up in class at the very end of class when we were going off the like when we were kind of going over this worksheet. We just didn't have time to finish solving them. Okay. So that's question 4. Now question 5 were some graphs, and again, I zipped through these graphs so fast. So let's take a few minutes and go through them a little bit more efficiently. Okay. So for question 5, it says graph each equation, and the first equation we have is 3y plus 4 equals negative 5. Hopefully what you notice is missing here is an x, okay? So when we're graphing in this two-dimensional world using the Cartesian plane, we always have an x and a y. Well, if we have a situation where one of the variables is missing, that means we can't touch that axis. So in this case, we have an x that is missing. That means we can't touch the x-axis, okay? So notice there's no x. That means we cannot touch the x-axis. We can only touch the y-axis. And the only way to do that in the Cartesian plane where we touch the y-axis but we don't touch the x-axis is if this is a horizontal line. So y only, horizontal, I can't spell, horizontal. So this is a horizontal line, okay? And when you have a situation where one of the two variables is missing, solve for the variable that you do have. So we have 3y plus 4 is negative 5. We want to get the y by itself. So the first issue is that plus 4. We need to move it to the right. So to do that, we would subtract. So 4 minus 4 is 0, which leaves me with just 3y. 3y equals negative 9. And we want to get the y alone, so we would undo the multiplication of 3 and y. So I divide both sides by 3, and that gives me y equals negative 3. So this is a horizontal line that crosses the y-axis at negative 3. Whoops, pretend that's perfectly straight. But there you have it. That's what your graph would look like. So when you are missing one of the two variables, it's kind of easy to graph. You just have to remember which is which. If so when you have only one of the two variables, if you're left with only a y, that's a horizontal line. If you're left with only an x, that's a vertical line. All right, so next up we have 2x minus 5y equals negative 10. I did not specify the method to use here, but anytime you have these nice, pretty integer values, look to see if the coefficients of x and y will divide into the constant. If so, intercepts is going to be an easy way to graph. So let's say we look for the x-intercept first. So the x-intercept is where this line crosses the x-axis, and it's always going to occur when y is equal to 0. So to find an x-intercept, you let y equal 0 and then solve for x. So we would get 2x minus 5 times 0 equals negative 10. Well, 5 times 0 is just 0, so that leaves me with just 2x minus 0, or just 2x. Now I have 2x equals negative 10, so I want to divide both sides by 2. Well, on the left, 2 divided by 2 is just 1, leaving me with 1x. And then on the right, negative 10 divided by 2 is negative 5. So my x-intercept is the ordered pair negative 5, 0. So that would be the point right here. Next, we want to find the y-intercept. And to do that, we let x equal 0 and then solve for y. So I get 2 times x, which is 0, minus 5y equals negative 10. Well, 2 times 0 is just 0. 0 minus 5y is negative 5y. So I get negative 5y equals negative 10. Divide both sides by negative 5. Well, the negative 5's on the left cancel. They just become 1. So I'm left with 1 equals 2. So that tells me my y-intercept is the ordered pair 0, 2, which is right here. We connect, and that is the graph of the line. Now, you didn't have to use intercepts, but intercepts are really, really easy for this particular example. All right, last up we have parts C and D. So for part C, you have a system of equations, okay? Well, when you have a system of equations, or well, not equations, it's inequalities in this case. When you have a system of inequalities, you want to graph each inequality individually, but on the same Cartesian plane. So graph them one at a time, but on the same XY axis. And then you want to look to see where the shaded regions overlap. So let's look at the first equation, or the first inequality rather. We have x minus y is less than 1. In a situation like this, I'm going to go ahead and solve for y. So I'm going to start by subtracting x from each side. X is on the left just becomes 0, leaving me with negative y, which is less than or equal to negative x plus 1. Now, I'm not done because I have a negative y. I'm not fully solved for y until I have a single positive y, so I do need to divide each term by negative 1. And since I'm dividing everything by a negative, all of my signs are going to change, and to compensate for that, my inequality symbol needs to flip too. So I get positive y, positive x, and then negative 1, and now I'm greater than or equal. Okay? So for this first line, or this first inequality, we have a slope of just 1 over 1. We have a y-intercept of negative 1. So the coefficient of x is always going to be the slope as long as you have solved for y. And the constant is the y-intercept, again, as long as you have solved for y. And we're going to connect these points with a solid line. And we think we're going to shade above because we have y is greater than, but we'll test a point to make sure. All right, so I've got my y-intercept, which is at negative 1 on the y-axis. From there, I need to apply my slope, which tells me to go up 1 to the right 1. So I'm going to go up 1 to the right 1, up 1 to the right 1. I could have gone down 1 to the left 1. I'd be on the same line. So just whichever way you need to go to get your points on. We want to connect with a solid line. And we think we're going to shade above. Let's go ahead and test a point. So as long as you don't go through the origin is going to be the easiest point to test. So I'm going to test the origin on my original inequality. So x is 0, y is 0. We want to see if that's less than or equal to 1. Well, 0 minus 0 is just 0, and 0 is less than or equal to 1. So that tells me I'm definitely going to shade above the line. So I'm just going to put a couple of little gentle marks there to remind me that I'm shading above the 1. We'll fill in the official shading in just a minute. All right, for the next inequality, let's graph it in blue. So I have x is greater than 2. Well, I'm missing a y. That tells me I cannot touch the y-axis, but I have to touch the x-axis, which tells me this is vertical, and it's vertical with an x-intercept of 2. So I can go ahead and start graphing a vertical line through positive 2 on the x-axis. I just need to be careful because I want to connect with a dotted line. And when we're dealing with horizontal lines, we can shade above and below. When we're dealing with diagonal lines, we can shade above and below. When we're dealing with vertical lines, we can't shade above and below. We either shade to the left for less than or to the right for greater than. So we're going to shade to the right. So let's graph a dotted line. And we need to make note that we're shading to the right, which means this little upper right-hand corner where these two lines kind of overlap, that's going to be our shaded region. So this right here is going to be where the shading overlaps. And we do need to be really mindful of the point where the two lines intersect. Since we didn't have two strict inequalities, or since we didn't have two or equal to inequalities, we can't connect these 2 points with a dot or with a solid line. It has to be an open circle. So let me say that again because I feel like that was really confusing. When you have a system of inequalities, you have to be mindful of where the two lines actually intersect, like the point of intersection, okay? If you have two strict inequalities, that means just greater than or just less than. If they were both just greater than or just less than, you would want to make sure you have an open circle where these two lines intersect. If you have two lines that have the or equals to, so they're less than or equal, greater than or equal, then you have to make sure the point where the two lines intersect is a closed circle. The issue comes up is, well, what do I do if I have one of each? Well, if you have one of each, it still has to be an open circle because you have to have a point that satisfies both of the equations. And if one line is a strict inequality, that means the points on the line can't be part of the solution. So in this case, this one right here, the points on the line are never going to be part of the solution. So we need to make sure we have an open circle where the two lines intersect. Okay? Last up, we have 4x minus 5 equals 7. We're missing a y, so that tells me I have to touch the x-axis, but I cannot touch the y-axis. So this tells me this is, again, vertical. So with only one variable, go ahead and solve for the variable that you do have. So we have 4x minus 5 equals 7. Let's go ahead and get the 4x alone to start. So we need to move the minus 5. We do that with addition. Negative 5 plus 5 just becomes 0. So I'm left with 4x equals 12. And then we need to undo the multiplication of 4 and x. So I divide both sides by 4. And this tells me x is 3. So this is a vertical line that goes through 3 on the y-axis, positive 3 on the y-axis. So this line would look like this. Okay, so that is the rest of the Unit 2 review that we did for our in-class activity on Thursday. We just didn't have time to completely finish going over it. So questions 4 and 5, I just kind of put answers on the board, but we didn't finish solving. So there you have it. That is the rest of that worksheet. Okay.